Okay, example 16 goes into two-line notation. With our one-line notation, it works just fine as long as our domain are a series of numbers, right? Because, we know the order that numbers go in. But if our domain is something else, some other set of symbols, then we have to actually specify this is the order. So remember, if we have, let's say that we have A and B, and this could be, A, B, C, and this could be X, Y, Z. And let's say that this is our mapping. That's our function. We could say, f of A equals Y, f of B equals Z, and f of C equals X, right? So those two are equivalent. We could write this lengthwise by saying A, B, C goes to Y, Z, Y, Z, X. And that right there is our two-line notation, which is kind of what I've been unofficially doing. I've been, jotting in the margins above each one-line notation the numbers to make it easier to read. That's two-line notation. That's all there is to it. So how do I tell with two-line notation if I'm looking at an injection? If you recall, with an injection, each member of the range is mapped to at most once. Well, I don't see any of the symbols repeated here, so this must be an injection. How do I tell if it's a surjection? That means that every member of the range must be mapped to at least once. I see all of the members of B there, therefore it is a surjection. And if it's both an injection and a surjection, it is a bijection. All right? So with two-line notation, I think it's actually much more intuitive than one-line. It might be helpful to write out two-line whenever you see a problem that has one-line notation going forward. That's all there really is to two-line notation. If you have any questions, ask in the forum below.